Hello guys, in this video I'm going to show you how to solve rearrange a linked list problem. So given a head of a single linked list, try a method to modify the linked list such that the nodes from the second half of the linked list are inserted alternately to the nodes in the first half of in the reverse order, right? So for example, we have this given input 1, 2, 3, 4, 5, 6, a total of 6 nodes, right? So our method should return 1, 6, 2, 5, 3, 4. So why is that? Back to the statement, the node from second half is inserted alternately to the node from the first half in reverse order. So it means we should have we should have two parts, right? Two halves of the linked list. We should divide into two halves. First, here the first half, the second half would be 4, 5, 6, right? And no. Uh, the second half here is inserted to the first half, but in the reverse order. So we need to reverse this sublist. So it will become 6, 2, 5, 2, 4, right? Okay, I've deleted. Then wanna take this sublist and insert it into this sublist alternately. Even though I call it insert, but the constraint here is that you're not allowed to modify the linked list, right? You're not allowed to use external space, auxiliary space for this problem. So we must somehow modify the pointer between nodes to bring it into this form of linked list, right? So how to insert this one to the first half? We first take one pointer 6, right? Take the first one in the first half, point the first one in the second half. 6 will point to 2, which is the next one in the first half. 2 will point to 5. Okay, and so on. 5 will point to 3. As you can see, they are inserted alternately. 3 point to 4 and point to 0. Okay, so that is it for this one. For these kind of problems, we also need to handle the case where the number of nodes are odd, right? In this case it is even, but in case it is odd, like for the example, there are 5 nodes in the list. So we need to do the same, right? We need to break it into two halves and reverse the second half and connect them together. Okay, let's try to code it down. I will write a couple important points. that we need to achieve here. First, we need to find the middle node, right? Because in order uh, to divide into two subnets, we must know the middle node, right? We must get access to the middle node. Okay, and then we can reverse the second half. Second half. Okay, so now combine them together. Okay, let's do it quick here. Find the middle node. Simple task that we've solved in. We've solved this task already, so I'm not gonna explain that again. Um, okay, so we need to find the middle. I will extract it out into a functions, right? Take in the head. Then reverse the second half. So after having the middle, I will reverse the second half, right? Reverse. Reverse will take in the middle node, right? We want to start reversing from the middle node, and this will return the new head of second half, right? The old head is actually the middle, and we need to return the new head, because for each sublist, for each linked list, we must get access to the first node, right? So from there we can start traversing head 2, let's say head 2. Okay, combine them together. I will write the logic right here. Okay, so first find the middle first, right? Function, let's do it quick here. Find the middle, take in the head node. In order to find middle, we want to use two pointer, slow and fast pointer technique. Slow will be head, fast will be head, right? And for each iterations, I want to get into a loop, right? First, leave it true here. For slow, I will move it one step forward at a time. Slow to the next. For fast, I will move it two steps forward at a time. But I only want to do this only if we do have the fast. The fast is not no, and we have the fast dot next, right? So the fast dot next can be no, but the fast dot next cannot be no here. So when the fast is no or the fast dot next is no, will exceed this loop, while loop, and at that time the fast is at the end of the linked list, and the slow will be the middle node, and I'll return the slow here. Okay, we're done with this find middle task, right? The second one is reverse. Reverse, we also take in a head, right? And okay, in order to reverse, I will need traverse. I will need to traverse the linked list, right? We'll start from the head, and I'm gonna use a working pointer. Let's call it current is head, right? So wanna get into a loop, and inside here we want, for each iteration we want to point the current node to the previous node, right? Is previous node. So initially previous will be node, right? For each iterations I want to point the current to previous, so I will do something like current dot next is previous, right? And in the first iterations current dot next will be node, right? The conditions to enter this loop is we have current, right? The current is not node. Okay, by reassigning current next the previous, by pointing current to previous, we're gonna lose the connection to the 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 next current, right? So I will need to save it before doing the assigning. Uh, Next up current will be current.next, right? And up and down here I will, before moving to the next iterations, we need to update the current and previous, and previous will be the current and the current will be next up current. So here, so gonna exit when the current is null, right? So when the current is null, this means we're done traversing the linked list, and the new and the new head of the sublist after it has been reversed is the previous, right? The current is null, so the previous will be the last node, and the last node will be the new head node, right? So I'll return previous here. Okay, so down here we'll start combine them together. We combine two sublist, two half of the linked list together. So I will need to use two pointers, one point to the head of the first half and one point to the head the second half. So let P1 will be head and P2 will be head 2, right? So I will start combining, right? We don't know the conditions yet, but let's see, uh, right? So here, in case we have two cases, right? In case the nodes, the total nodes is even, then the middle will be, in this case, it will be 4. Here the first half, here the second half, right? Oh, let's delete this. So the first half would be, okay, let's look at these. Okay, so here is P1. P1 start from here, P2 start from here. So first P1 will point to P2, right? And then P2 will point to next of P1. So 1 point to 6, 6 point to 2, right? So that is the logic. So p1 dot next will point to what? P1 dot next will point to p2, and p2 dot next will point to what? The next of p1. But by doing this assignment, we're gonna lose the connection to previous next. I'll say the old neck of p1, right? We're overriding the next of p1 here. So before that, I will say next of p1 will be p1 dot next. Then I will point p1 to p2, right? So now after that, p2 can point to next of p1. We also want to save the next of p2 as well. So down here I will update p1 and p2 right before jumping into the next iterations, right? Okay. One point to 6.2. Okay. So after here, after this, after done with this part, wanna reassign. Initially here, we have two pointers that point to the first of two sublets. And after doing these operations, we're gonna move up, right, to continue with the next node, next nodes of two sublets. And here we've already set the next of the original next of p1 and p2. So here I can update p1 to next of p1 and p2 to next of p2. And the conditions here that I want to condition so that we can get into the loop is probably only when we have both p1 and p2, right? And if p1 or p2 is no, we probably don't want to get into getting here. So p1 and p2 is not no, then we will get here. And if one of these is no, or both of these is both these are no, like see, right? It means we're done with the combining part, and I'll return what? Return the head of the head after rearranging is actually same as the old head, right? So I'll return the head here. If I run it now, it probably it's probably gonna be failed, right? Just 3, 6, because here we're probably we're missing some corner case, I guess. Okay, well, we have one passing test. It is test one, test two is passing now. So, so what happens when the failing is maybe because the failing maybe happens when the pointer reaches the end of the sublist, I guess. So let's see what happens when two pointers reach the end of the sublist here. So after here is 6, point to 5, point to 4, and point to no, right? It is actually this reverse, mm, reverse part, right? And initially it's previously no. So here we reverse 6 to 5 to 4, and 4 we point to no. Okay, so mm, 1, 2, 2, 2, 3. 3 is actually still point to 4 here, and 4 we point to no. Okay, so at this snapshot, we're gonna do the same logics as we did previously. So first 3.24, right? 3.24, then 4 point to next of 3, which is again 4. So it will be something like this. And after that, we will move on to pointer, right? This will point to 4, and this will point to no. So when it exceeds this loop, because one of these are no, one of these are no. So at that time, I will return head here. So what is wrong here is so at the time, what happens is our final linked list is kind of circular, becomes circular here. 4.24, 4 point itself, right? 4 point itself, so it will cause circular linked list here. So at that time, how to fix this one is actually at that time the P1 is pointing to 4 now, right? So we probably want to reassign the P1 here. We want to point the P1 to no instead, right? So here I will point P1 to uh, no, but only when we have a P1. Be careful, like whenever you access the next of a node, always check if it is not null, right? only have we have P1, I will be assigned the next to here. It should be working, I think. Okay, it works. So how about the odd case? How about the odd case? Let's I will show you how it what happened behind the scene here. 4.2 sorry 5.24 5.24.20 1.22.23.24 and 0.20. Okay, so same logic here. 1 plus 0.25, then 0.22. That would be the first iterations, right? We have 2 pointer like this, and after that we're moving 2 pointer forward, and now 2 and 4. Again, same logic, 2.24 and 4 point to next up 2, which is 3. Okay, next. So now P2 is no, so we exit the loop, right? So now the last node is 3, and 3 is currently pointing to 4 here, which is not correct. We want 3 here must point to no instead. So it is exactly this logic that we fix it. If P1 we have P1 not no, then point P1 to no, right? So uh, so that is it for this problem. So thanks for watching. See you in the next video.